Betelgeuse, the bright red star at the shoulder of the Orion constellation, has been exhibiting some bizarre and mysterious behavior. Astronomers have observed a sudden 250% increase in its brightness, sparking speculation that the star might be preparing to go supernova. However, the timing of such an event remains a mystery. It could happen tomorrow, during this very broadcast, or it might not occur for another 100,000 years. Will Betelgeuse go supernova? What happens when Betelgeuse goes supernova? What happens when Betelgeuse goes supernova? Join us as we delve into the depths of space and explore the mysteries surrounding this celestial giant, which has the potential to reshape our understanding of the universe. Even if you're not familiar with its name, chances are you've gazed upon the magnificent Betelgeuse. This radiant, reddish star shines brilliantly in the Orion constellation. Its size is astonishing. If Betelgeuse were placed at the center of our solar system, its outer surface would extend beyond the orbit of Jupiter. To this day, its colossal presence continues to captivate astronomers and stargazers alike. Unlike most stars, Betelgeuse changes before our eyes because of its relatively close proximity to Earth, making it one of the few stars whose surface details can be studied directly. This accessibility has made Betelgeuse a prime candidate for studying the life cycles of massive stars. Betelgeuse is classified as a semi-regular variable star, meaning its brightness fluctuates, sometimes dramatically, as it moves steadily toward its eventual grand collapse into a supernova. Recently, however, the star has become even more intriguing due to unexpected fluctuations in its brightness that scientists still struggle to fully comprehend. Its brightness has varied more than 50% at times, and on May 20th, 2023, it increased by an astonishing 150%. Astrophysicist Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics noted that Betelgeuse is now the seventh brightest star in the night sky, climbing from its usual 10th position. If you're in the southern hemisphere, you can see Betelgeuse shining brightly in the early evening. This unusual brightness surge has astronomers scratching their heads, prompting questions about whether the star is preparing to go supernova. Betelgeuse's current behavior can be traced back to a peculiar event that occurred between 2019 and 2020, known as the Great Dimming. During this period, Betelgeuse went through an unexpected and unprecedented decline in brightness, leading some to speculate that the star was on the brink of a supernova explosion. However, the star's brightness eventually returned to normal levels, though the experience left scientists with more questions than answers. In May 2023, Betelgeuse's brightness again surged unexpectedly, fueling further debate and anticipation among astronomers. Betelgeuse's fluctuation in brightness is primarily due to its classification as a semi-regular variable star. It has a typical brightness cycle lasting around 400 days. However, since the Great Dimming, the star's cycle has shortened to approximately 130 days, signaling that it is undergoing significant changes internally. The sudden increase in brightness is particularly puzzling because such rapid fluctuations are uncommon for stars of Betelgeuse's size and stage in its life cycle. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, points out that we are witnessing the final stages of a big star's life in real time, which is a unique and unprecedented opportunity for astronomers. Will Betelgeuse go supernova? The big question remains: when will Betelgeuse explode? Experts are uncertain, as predicting when a star will go supernova is a complex challenge. Betelgeuse is currently in the final stages of its rapid evolution. However, there is still debate over which phase of fusion it is currently undergoing. Some astronomers speculate that Betelgeuse is in the earlier stage of fusing helium into carbon, which can last thousands of years. Others believe it could be further along in its life cycle, nearing the end of its core carbon-burning phase. If this is the case, a core collapse and subsequent supernova explosion could happen within just a few tens of years. However, most astronomers, including those from NASA, caution that Betelgeuse is unlikely to explode anytime soon. NASA suggests that Betelgeuse may not go supernova for another 100,000 years. Astrophysicist Jared Goldberg of the Flatiron Institute notes that while Betelgeuse is destined to explode, this soon could mean within the next 10,000 to 100,000 years. Despite the uncertainties, one thing is clear. The current changes in Betelgeuse's behavior have given astronomers a front-row seat to study a star in its late evolutionary stages. What happens when Betelgeuse goes supernova? If Betelgeuse does explode, it will be an event of cosmic proportions. The explosion would be so bright that it would be visible during the day for weeks, possibly even casting shadows at night. This spectacular display could last for about 100 days, fading gradually over time. At its peak, Betelgeuse could shine 10,000 to 100,000 times brighter than its normal state, potentially becoming the brightest object in the sky after the sun and moon. Depending on the strength of the explosion, its remnants could be as bright as a quarter or even half of a full moon, concentrated into a single point of light. The initial signs of the supernova's arrival will be subtle yet unmistakable. Neutrinos, ghostly particles emitted during the star's collapse, will sweep over Earth, triggering detectors around the world. Then, high-energy photons will escape from the expanding cloud of stellar debris, marking the commencement of the real cosmic fireworks. The explosion will be bright enough to be seen with the naked eye, and no special equipment will be needed to witness this celestial event. A clue to Betelgeuse's future? Betelgeuse's great dimming in late 2019 and early 2020 captivated astronomers and sparked debates about the star's imminent fate. During this period, Betelgeuse's brightness dropped by about 60%, an unprecedented change that could be seen even with the naked eye. Initial attempts to explain the phenomenon suggested that it might be a pre-supernova phase. However, subsequent investigations, using data from telescopes like the Hubble Space Telescope and the Very Large Telescope in Chile, indicated that the dimming was caused by a surface mass ejection and the formation of a dust cloud that partially blocked the star's light. Scientists have since proposed that the Great Dimming was a combination of convective cell activity and a massive dust ejection event. In January 2020, the surface of Betelgeuse was observed to have a significant dark spot, likely caused by the cooling of a convective cell that led to the condensation of gas into dust. This event marked the first time such a significant surface mass ejection had been observed on a star. The aftermath of the Great Dimming has left Betelgeuse in a state of flux, with its usual 400-day pulsation cycle disrupted, providing a unique opportunity for scientists to study its internal dynamics. Betelgeuse has intrigued humanity for millennia, appearing in mythology, literature, and scientific studies. Ancient cultures, including the Egyptians, Greeks, and Aboriginal Australians, have recorded observations of Betelgeuse's variability. In Greek mythology, it is associated with the constellation Orion, while in Egyptian mythology, it is linked to Osiris, the god of the underworld. The star's name itself comes from the Arabic term Bat al-Jawz, meaning the giant's shoulder. Interestingly, ancient Greek astronomer Claudius Ptolemy described Betelgeuse's color using the word hypokairos, suggesting that the star may not have always had its current reddish hue. The Aboriginal Australians, who have been observing the stars for over 65,000 years, have oral traditions that mention the variability of red giant stars like Betelgeuse. This long-standing fascination across cultures reflects humanity's deep-rooted curiosity about the cosmos. Today, scientists continue to closely monitor Betelgeuse as it recovers from the Great Dimming. Its interior is oscillating as it goes through a process of recovery from the mass ejection event. The fluctuations observed on its surface resemble a wobbly gelatin dessert, hinting at the internal turbulence within the star. The current state of Betelgeuse provides valuable insights into the mass loss processes of red supergiants before they explode as supernovae. Despite its recent behavior, there is no immediate danger of a supernova explosion. Astrophysicist Andrea Dupree has been piecing together observations from various sources, including the Hubble Space Telescope, NASA's Stereo A, and the American Association of Variable Star Observers, AVSO, to construct a coherent narrative of Betelgeuse's activity before, during, and after the eruption. The data indicates that surface mass ejections and coronal mass ejections are fundamentally different phenomena, revealing new aspects of stellar evolution. In summary, Betelgeuse remains an enigmatic star whose recent fluctuations and mass ejection events have sparked global anticipation. Its unprecedented behavior offers a unique opportunity to study the late evolutionary stages of massive stars and challenges our understanding of stellar dynamics. While its supernova explosion might not occur for thousands, or even hundreds of thousands of years, Betelgeuse continues to be a focal point for astronomers and a source of endless fascination for humanity. As we gaze up at this radiant star, we are reminded of how much we have yet to learn about the universe. Betelgeuse, with its dramatic fluctuations and unpredictable behavior, stands as a celestial mystery that may one day provide answers to some of the cosmos's most profound questions. Until then, we watch and wait, hopeful for a grand celestial show that will light up our sky and deepen our understanding of the stars.